Yeah, we set out. I'm going to try and really talk like lightning because I have a bunch of information. But we have customers coming in and they have uh, questions about the performance of krbd or librbd or krbd versus librbd, and this is mostly related to Qemu um, workloads. Um, so several customers have asked these questions, and a lot of times it is formulated as a feeling of slowness. So I feel like librbd is slower than krbd, or I feel like this workload is slower than that workload. So we set out basically to see how we can show these differences. What we set out to do is we wanted to make sure that we gather data um, that makes us able to compare the performance characteristics of the two major Ceph clients, the major RBD clients, so the librbd user space client and the krbd kernel client. We wanted to make sure that our results are comparable and that we could present them not only here but also to our customers. And we want to make sure that we are not talking about our feelings about performance. So we set out with a clear goal. We wanted to define clear scenarios to test, define clear tests that are comparable or the results are comparable, and then present these compared results. What we often find is that somebody will think something or feel something about the performance, but not be able to describe what the exact test was or what the exact scenario was. So we feel that it's very important. Still, I'm here talking about my feelings. We feel like it's important. So there are four major scenarios that we have defined for this particular test. It's Qemu using librbd, and we will be doing the test inside of the virtual machine using libio engine. Qemu using krbd, also via libvirt, same IO engine. Then we will be testing the host librbd. So that's bare metal on the same host that the virtual machine exists on. And we will be using the librbd IO engine of VO IO. And we will be testing the host krbd performance on bare metal with the krbd mapping, and the IO engine will be libio here. Now the tests are for us, what was important is to see different types of results. So Guido did a talk yesterday about the importance of testing with QDepth of 1. So we have that as part of it, but we also test with QDepth of 32 and 128 because it amplifies problems and it makes it much more visible, and it can also sometimes reveal different types of problems. We did 5 for each scenario, and each test combination we did 5 runs. Non-sequential, so we did one run for each of the scenarios and then the second run for each of the scenarios, so they are not consecutive. We did a random read, random write profile. Block size is 4K, 64K, 4 MBs, and the IO engines, like I said before. And we are only looking at IOPS right now, just because it's a handy number that is easily compared. We try to avoid any optimizations or any caches or stuff like that, so it's all direct, and we try to test the actual client performance and not the local caching of the clients. So the setup is not very interesting to me because it's what we are trying to achieve here is not trying to get the highest speeds or anything. We are just trying to get results that are comparable, and that was our goal. Not do the best, have the best Ceph cluster or have the best setup. this is a practical setup that is running production for this customer. So here we have our results of the krbd versus librbd in a VM. And this is not really the vastly different performance results that were felt by our customer, and they are not really the what we see in the marketplace. But this is what we saw in this test environment. So we really tried to focus on the comparability of these numbers. So in the bottom you can see the increasing queue depths and the increasing block sizes. And I think it's quite interesting because if we compare the numbers here between librbd and krbd, and we do an average of the average of the average in percentages, then they are 100%, almost 100% the same. So the krbd performs on average at 100% of the librbd VM. And this is VO running inside the virtual machine using libio. Now, this is, it almost looks like the performance goes halves, but it's not. If you look at the left, you can see that the scale changes. So if we look at the krbd versus librbd on the host, there we can see massive differences. And here we can see that the krbd, the queue with block size of 4K and a queue depth of 128, it tops out for this cluster at 45,000 almost, while the librbd tops out at nearly 20,000 for just about everything. You see that if you increase the block sizes, then the performance does take a dip a little bit, but that's to be expected. So this is the krbd host is tested with libio in VO, and the librbd host is tested with librbd in VIO. Here we have a little bit more comparison between the queue depths. What you see here is that the librbd VM and the krbd VM are roughly the same again. So librbd host and krbd host are vastly different, but the VMs are generally the same. So there's another ceiling there that we are encountering. Here, this is the block sizes, small versus large, and there was a bit of a surprise here to us, is that the krbd performs a little bit worse than librbd when the block sizes are 64Ks. I don't have an explanation there. We just have the results, and we haven't delved into why this is, but I'm very keen to see why. Now, our notes of interest for these tests are that librbd has a performance ceiling. In this particular setup, it's about 20,000 IOPS. Last Monday, Ilya had a great talk of the RBD update, and he talked about the same ceiling, I think, but maybe Ilya can confirm this. The librbd and krbd and Qemu are about equal, the performance. The average of the averages, like I said, is about 100%. So krbd performs at 100% of librbd in this case. When we compare librbd versus libio on krbd, we do get very different results. So we get an average of 150%. So krbd performs at 150% of librbd. And at 64K, Qemu krbd performs a bit worse when compared to librbd. With 4K and 4 MBs, it performs better, which was interesting, but we haven't had the chance yet to look into it in detail. So for us, the next steps are, almost. So the next step is basically test with Pacific, especially based on the talk of Ilya, and then compare the results again. Are there any questions? Thank you for your time. But
yeah, this is exactly the thing that I talked about, and it's interesting that an independent test sort of confirmed it right down to the same number, because what we saw was somewhere between 20,000 and 30,000. So some, with some configurations, you could push it a bit higher. But it's again, the fact that you also arrived at the same 20,000 number is just another confirmation.
Yeah, so I think the 20,000 is probably based on the system that I was using, and not on a really practical limit of librbd. I think we did not set out to do everything the fastest. We just set out to test this system, and this is what this system did. But yeah, the 20,000 seems to be the upper limit of librbd in any situation. And the same limit seemed to be applicable to Qemu, actually. So I'm not sure why, but it seems to have the same results. But now I'm going over time, sorry.
Couldn't be some throttling not disabled.
It could be, maybe. I don't know where, but we will publish our FIO configuration so that everybody can also test that with on their own systems. I don't know of any throttling that we encountered. I don't know if you have seen the talk of Ilya. I highly recommend it because it's a good update on where RBD stands and where RBD is going. And there are some clear explanations in why the ceiling exists and what they are doing about it.